Okay, hi guys. Yeah, welcome back to the our brand new session of algorithms and programming in C. So here we are basically focusing towards writing a program in C. C is one of the most fundamental programming language, that is most general purpose programming language. Okay, and not only about programming, we'll also learn how to write the algorithms to solve the problems that are particularly towards programming problems in C programming language. Alright, so with this fact, and also I will present you some kind of advantage uh, for C programming language. It's like C is a procedural programming language and it's a very fast programming language. Alright, so and it is the fundamental for learning some object oriented programming language like C Sharp or Java. Alright, so this is like a this will provide you some kind of fundamental building block to learn some other object oriented programming language which has very high um, implementation, like high user friendly implementation, like for example creating applications, right, using object oriented programming language like C Sharp. We can create applications in Apple, whereas using Java you can create applications in Android or some other web applets, right? So these are the advantages of learning C and learning how to write algorithms in C. So we will be dealing much about the fundamental concept of programming in C, and then we'll slowly we'll just build our knowledge in algorithms, okay, and writing programming to solve the programming problems, okay, and we write the algorithms to build up our own algorithms and just learning some already provided algorithms. All right, so that's it. So at the end of the course you guys will be able to dynamically allocate the memory, so using the pointers and dynamic data structures in C language. So you guys will also evaluate the algorithm complexity, so you know how to evaluate the algorithm complexity and improve the efficiency in terms of execution time and or memory allocation. Alright, so write standard algorithms to solve basic problems like sorting, searching, etc. And you guys will also manipulate the complex data structures like linked list, stacks, queues, heap, trees, hash tables, and graphs. Alright, and write the modular programs in C language, adopting several programming paradigms such as recursive programming like greedy approaches, dynamic programming, and memorization. Alright, and with that you guys will also exploit some tools for program development and problem solving, like that is based on design of data structures and algorithms. So it's like designing the data structure, that is one of the fundamental and very core concept, okay, that you guys will know here, and also designing the algorithm to solve the programming problems, right? And I hereby present some contents that I will be discussing here throughout the lecture, and those are like algorithm analysis, asymptotic analysis, and worst case complexity, right? Sorting algorithms, quadratic sorting like selection sort, insertion sort, exchange sort, and linear sorting, counting sort. Alright, and logarithmic sorting, merge sort, and in logarithmic sorting we'll be doing something like merge sort, quick sort, and heap sort. Alright, I'm saying this linear sorting because the complexity is very linear here. Okay, linear sorting means the complexity of sorting using this kind of algorithm will be linear, whereas quadratic sorting, the complexity for using such kind of algorithm, that is selection sort, will be quadratic. You guys will know much in depth, okay, in the following course that is coming. And the static and dynamic data structures and the implementation in C. Alright, and the memory representation and allocation of data, and runtime memory management. So overall about memory management, how it is done, let's see. uh, because the in procedural programming language that we are doing, that is C, memory management is done by the programmer. So we will be responsible towards the memory management. Either you can use the huge chunks of memory, or you can limit the memory so that you can improve the performance, so that you will just not use up all those kind of memories that are available. Okay, so you just use the do the memory management to resolve the problem of memory. And you guys also have pointers, that is are references to objects, link data structures such as stack, queues, and list. Strategies, strategies for data structure choice and design, like what kind of strategies you will do for designing your data structure, that are like modular programs and modular implementation of algorithm and data structure will be done here. So a C language implementation of a program based on a multiple source and header files are done here. That is recursion. And this is one of the fun and one of the most important. Just be careful. This is one of the most important concept in C programming language, recursion, because it's going to make programming much simpler, much easier, and much faster. All right. And the recursive program and recursive reasoning. And for your prior knowledge, C language is one of the fastest programming language that is used nowadays. Alright, it's one of the most fastest programming language. And backtrack and implementation of recursion, discrete mathematics such like sets, relation functions, graphs and trees, abstract objects, collection of objects, and abstract data types, ADTs. So example of modular composite data structures. That are arrays of list, multi-list, and also linked list, stack, FIFO, that is first in first out, generalized queues, priority queues, heaps. So algorithm paradigms, divide and conquer, the greedy paradigms, okay, dynamic programming and recursion with memorization. So also you guys have like problem solving techniques like data structure and algorithm analysis and design strategies, some research and optimization problems, data structure for symbol tables, that is like hash tables, something like binary search trees, hash tables, right? And graph algorithms like depth first and breadth first visits. So application of visits and sort path, minimum spanning tree, such will be the topic that will be discussed in the following lectures. Alright, and okay, so for today I have decided to do, that is like basic for C. That will be something like I will be giving some basic concept that will be required to go further in depth towards exploring such kind of contents that I have provided. Alright, so before that we need some kind of basic concept, and I will provide the basic concept right now. So one of the basic concepts for C, as you guys have I think already gone through the basic concepts for C, that are like what is the program structure for basic C programming language. That is something like you need a header inclusion, and the header inclusion are those like which include the header files. Okay, so some header files like standard input and output, standard libraries, those are included, and these are the header inclusion, and they will start with a certain symbol, that is a hashtag. Alright, and we have the int, that is the return type, the name of the main function, whereas also you have the input parameters that are passed here. That is a void here. In case here is a void parameters that are passed. No, that means no parameters are passed here. And you guys have the definite. This is a curly bracket. This is a block, as I have also provided here. This is a block. That means it is this block is totally dedicated to this function, that is the main function, and there's a definitions inside the function. You guys, inside the block, inside the function, inside the block of this main function, we will have definitions, the instructions, TIONs, this instruction, and the return value that will be returned by this main, that is a of type integer. Alright, and followingly you guys have block. As you know, the block, that means all the variables are within this block. Like we have the area of response, or something like the area where the variables are available. Okay, like something like a global and local variables that you will be knowing. So here this is whatever variable that is defined in these definitions, okay, will be locally available here. Okay, whereas the variables that are outside this block, okay, those will be the global variables, and those will be available over whole another any kind of blocks that you make. Okay, and some identifiers like constants, variables, type, functions, few of them are the reserved keys. So some identifiers are also there, like constants, variables, types, functions. Okay, we will be knowing with dealing that. And the comments in C programming language are usually starting with the slash, black slash, with this star in, and like this, with this black slash and the star sign, you can write any comment here. Okay, there is any comment that you write between this block. Alright, now we have a preprocessor commands. So as I already specified before, in this header inclusion, you guys will also this header inclusion is this one, this preprocessor command. That is, this is a special command that is provided to the preprocessor, that it will include those specified header files. Okay, any header files that is specified within this smaller than and greater than symbol within this block, whatever, like you can, those header files are like this, can be anyone, like standard input output header files, standard library header files, string.header files, or math.header files, linux.header files, code.header files, ctype.header file, or assert.header file. Okay, for your particular information, standard input and output.header files will include all the libraries that are essential for doing input and output operation in C programming language. Like for example, an input and output operation you can use like the functions like printf for performing the output, whereas for input you can use like scanf, okay, to scan the input, something like this. Alright, standard library can include some other extra functions, whereas okay, and math.header files will include some kind of mathematical functions that you can perform. And also there are some float.header files, ctype.header file is usually for the character. Okay, it's like usually the libraries for characters and something like this. Also, or you can also use this preprocessor command in this form, not only in a such angle brackets, but also in this double quotation you can include the header files. And secondly, those preprocessor, first this one is the including the header files. Okay, the preprocessor commands for header file, including the header files. Now these are also the second one is this define preprocessor command, that is command that is you are using to define. Okay, for example, you can define the id with this expression. For example, you can also define like you guys can define n equals to like 1000. Alright, so n is a value, so whenever n is encountered inside the program, that will result to 1000. That means the value of n will result to 1000. Whereas also you guys have types, like certain kinds of basic types, those fundamental type provided by C are character which represent a character, that is A, B, C, D, some kind of characters like this, okay, which we use. Integer, like integer or something like, for example, integer value like 0, 1, 2, 9, okay, like till okay. So any kind of numbers that are numbers are integer numbers. Floating point numbers are those numbers like 1.0, some floating point numbers are there. Void means like it's empty. Like you guys can also have long, short, sign, on-sign. Long, short, sign, on-sign has this special meaning. And long means you can have a certain value. Those will be something like 16-bit, whereas int is like just like 8-bit, whereas short means just like something like the 4 bits, or sign, on-sign means like only positive numbers are signed, and on-sign means like any number, okay, something like this. Then these are the fundamental types, and you guys can also create your own type, own type, okay, and those I will do just little bit later. Okay, you guys can also use a special command that will be a structure to create your own type of a structure, okay, that you will just know just a bit later. And now a cast conversion is something like any expression, whatever this expression returns, will we can cast it so that it will, the returning value of this expression will be casted, and the return value will be of type this one, that it is casting, okay. So casting is usually done by specifying the type, the name of the type inside a round bracket, and it will always occur in front of the expression, whichever the expression we are trying to cast, okay. You can just inside the round bracket you just type in type, or you just put the name of the type you want to cast. Whereas like you can also use the type define. This will just define the type with another synonym name, okay. For example, you can also type define integer with any name, like for example type define integer with any name like my type, okay, any name. And now whenever you use my type, then this will act as an integer inside the C program, alright. And also you can use the size of this keyword to get the size of this type. Like for example, you can, you guys can also check it from your code blocks. Here I am using code block as a main platform to run C programming language. For example, you guys can use here similarly. This is the way how you standard live, okay, support. So let me do one something like printf is a special function for returning the doing output. Okay, I want to just check the size of the type int, and this is a new line character of int. Let's see that it will work or not. And just while returning, we just return 0. Let's see if it returns or not. Yeah, size of integer is 4. 4 bits. Okay, such a as I have, this is a type. You just put the type as I have, like as I was telling you, there were some fundamental types, right? Some fundamental types of character, integer, float, void, okay, long, short, signed, unsigned. And here you go. You can just now test what is the size of the particular type by yourself. Okay, similarly, like I want to test the size of all the types. So let me let's just copy and paste it. And right now I want to press after integer I want to put character size of char, right? And then I want to put the size of a float. And here the float. Now I want to see the size of double. Double, yeah. And lastly I want to long. And let's do for the short. You can see immediately. Alright. And long, short, like sign, unsigned also. Copy this so that it will be easier. And so immediately you can see the size of. Okay, now let me just run and see what's the situation here. You will see, look, for integer it was 4 bits, for character 1 bit, floating point 4 bit, double 8 bit, that is a byte, long 4 bit, short 2 bit, signed 4 bit, unsigned 4 bit. And okay, let's close it for the moment. And that's it. Alright, just checking out the particular size of this size of the type. Now we have also constant usually defined method as defined construct, as I was already dealing this, and this define preprocessor command is going to define a constant, and this constant will have always the value 1000, right? And some keynotes are 5 is an integer. This 5 is an integer. Okay, in C program when you use the 5 like this, 5.5 is a floating point number, as I was telling you. Whereas this 5 with a single quotation mark is a character. Always be careful. Whereas a 5 with a double quotation mark is a string. And these are the keynotes that you guys have to understand. And now for variables, like variables are declared within a block. As I was telling you, this is a block. This curly bracket is a block, and inside the block you define a variables, and with the following syntax, that is a type. First define type, and secondly the variable name. Terminate by this semicolon, not semicolon, yeah, so it's a semicolon. And some arithmetic operators are something like equals to, addition, and like minus, multiplication, division, modulus, increment and decrement operators are also here. Whereas relational operators are greater than, equal to, equals to, double equals to, be careful. Whereas not equals to, less than or equals to, and less than. Whereas there are some logical operators like not, and or. Alright, so as I was discussing you, input was like scanf is a special function for standard input, that is included in your standard input output. header file. And the format that we use is the following format. Like for integer values you use ampersand d, it's not ampersand, it's a percentage d, whereas percentage f is for floating point numbers, whereas percentage c for characters, percentage d for the again the integer numbers, percentage s is for strings. Alright, now for standard output you are using the printf function with the following format and the expression name. Format can be any format, but also you can use the name and character and the tab character. Now some conditional constructs. And what are some conditional constructs? And these conditional constructs are used mostly for checking the conditional statements. Alright, so if there is certain expression, then you perform certain instruction, whereas else you perform certain another instruction. Alright, and there are some switches. Switch is another conditional construct that is going to switch depending on the case. Okay, you have to switch this expression depending on the case. Like if the case is this constant, then you have to perform this instruction and you break. Now if the switch is this case, that is constant 2, then you perform another instruction and you break it. Whereas lastly you default in default case you are going to perform this default instruction, it is another instruction and you break it. Be careful in switch statement. You have to this in switch conditional expression. You have to be careful to break the statement. And now some conditional expression are. This is one of the most used conditional expression. And what is it going to do is like is in this form. And what you are going to do is like this expression. This is a condition. What this expression one, that is, if this condition is true, then this expression is followed. Okay, it follows this expression, that is expression 1. In case the first expression XPR is true, whereas if this expression is false, then this expression 2 will follow the condition, and this is the condition. Alright, that means this expression 2 will be executed. Now some cycles. Cycles are something that are the loop, and looping is usually done to perform the job or task faster. That means to reduce the computation time or to reduce the like looping means it's like you can loop 1000 times. Okay, you do not have to write it 1000 times. You are just looping it 1000 times. It is repeated. It is looping. Okay, it's just cycling itself 1000 times. That means the same instruction is just repeated. Alright, and this is one of the fundamental concepts that you guys have to understand in C programming, because by this means of looping you are going to make or write programming much easier, because you do not have to write the program 1000 times even if you are repeating it, because you are just repeating it 1000 times by just writing the number 1000, right? And look in the cycles. To use the cycles, you have to use certain functions like certain like while, and in case of while you are using just while expression and just providing the instruction. Okay, while certain condition you just loop while the condition until and unless the condition satisfied inside this round bracket, you just perform this instruction repeatedly until the and on. Okay, now for the for loop you have the three expression. That is, first is the instruction, which is terminated by the semicolon, then the expression, the same expression here, right, and the instruction 2, and similarly the instruction inside. for loop, right? So with that for loop we'll also have a do while loop that is going to do at least once. Okay, so this loop is going to do the instruction, that is going to perform this instruction at least once, while even if the case, like this while condition, this expression satisfies or not, is going to do this instruction at least once, whereas in this while condition, while loop, we are not going um, to perform any kind of instruction until and unless the expression satisfies or the condition satisfies. Alright, so yeah, and here is the particular note that you guys have to understand, that is this note is like for you can break or continue. Okay, so if you are going to break it, it forces the termination whenever it is used. That means what, like it forces the termination whenever it is used, means like whenever you use the break. For example, you are going to use the break for the for loop, then whenever it is used, it is going to force the termination, and the what is going to happen is like the control from this from that particular position where you are using the break statement, that the control passes to the like back to the original context. Alright, that means if you are going to use the break inside the for loop, then the termination, the it will terminate, and the for loop will terminate, and the control passes back to the initial position. That means like for, then it will the for loop, like the loop will terminate here, and then another immediately from that termination point, the another instruction will be like the for loop. After for loop, the another instruction will be executed. And in case of continue, it forces the next iteration take place. That means if you are using the continue inside the for, then this particular will not loop will not with that with any kind of condition. Okay, from that condition, the next iteration will start. Okay, it will continue, will take place. That is keeping any code that is in between, okay, between this instruction. And for the for loop, the continue statement causes the conditional test and increment portion of the loop to execute. That means the another loop will execute in case of continue. Another loop means another instruction of the whenever you use the continue statement. Whereas for the while and do, while continue statement causes the program control pass to the conditional test. Right, and guys, with that concept, now you guys have like the arrays to discuss, and let's investigate these arrays. And these arrays, like how do you define these arrays? Then there are like two ways of defining the arrays, like two types of arrays. There's monodimensional and multi-dimensional. Monodimensional are single dimensional array, that is like and the array consists of same type, the 1000 elements. Okay, can you define here? That means the array consists of same type of elements, and with numerous elements. Like numerous means ranging from 1 to 1000, or how much dimension you provide, millions or billions, how much dimension. It's like monodimensional arrays, that is having a single property. Multi-dimensional arrays are the arrays of same type of elements having 2 or 3 multi-dimensional properties, that is dimension 1, dimension 2, in such a way like you have like multi-dimension, properties. And whenever you use such kind of dimension, the size, you can also define by using the preprocessor element. Alright, so how do you access this kind of arrays then? mono are accessed using just like by providing the index, whatever index you provide. Okay, so that particular index element will, can be accessed, okay, from that block of that array. So for also for the multi-dimension, this it works in the same way, like you just have to provide the index and you can access the particular indexed elements. Alright, and for initialization, for mono, you are just equating with the value provided here, as I have provided here. And also for multidimensional, you can just assign the value in such a form. Alright, okay, so by that investigation, now let's investigate what is the functions there, and how do you define the functions. Like you have a certain format, and those format for definition or to define the functions are like, we have a type firstly, what type the function is returning, that's the return type, and this is the return type, the function name, formal parameters, whatever parameters you are passing, and inside the block, that is the curly bracket, you have the local definition and the functional body. And spelling is body. Okay, how do you call this function? Then you call this function by using the function name. You can call it inside a main function, that the main function is going to call the other sub functions. Like when you call, you have to pass the actual parameters. Whenever whatever actual parameters you want to pass, you pass it while calling with the function name. Okay, and how do you declare the function? Is like declaring is you have just the type that is declaring as a prototype. Okay, as a, you have to declare it always in front of, like, or before the main functions, right? You are just declare it by using the type, function name, and the formal parameters. And also don't forget this kind of termination. Terminating the function, you have to write the semicolon. So and for variables, as I have already noted it, you guys, like, there are local variables which are inside the block and global variables which are outside the block. Alright, so how do you define the pointers then? So here the pointers that you guys have to investigate is like, for defining, you have to have a certain pattern, and this is like a type. Firstly, what type, for which type you want to create a pointer, so that it is going to point that particular type, and is like the type firstly, the star sign, and the pointer name, and this is going to point to that particular type. So how do you assign a value to the pointer then? Assigning the values are in such a way that the pointer name, including with the star sign, is assigned or equated with the values or a variable name. Whereas if you just provide the pointer name without the star sign, then that is, star sign is the pointer sign, then we are just providing the address of the variable. And this operation of the pointer can be performed by using comparison. Alright, so like, for example, you can compare the pointer name with any values. Like, from the pointer name is a null value, then is going to point to the null. That means you can check by providing such a comparison. And okay, so for discussing the types of parameters that can be passed out, there are various types of parameters that can be passed, and those are passing parameters by value, and secondly passing the parameter as a reference. So you can check out here is like I am passing the parameter by reference. So if you first I define the array of certain dimension, I have an array of a particular type with a particular dimension. Then for a particular function I pass the parameter, and I pass it by reference, means I pass it by reference. How do I pass it by reference? The array, so just providing the name of the array will pass the parameter as a reference. Whereas if I pass the array with a particular index, that means I am passing the particular value. Alright, and you can, you can not only pass the parameters to the function, but you can pass the parameters to the whole main program, or like a whole program as a whole. And that means like as a whole you can pass the parameters to your program. That means you can pass the parameters like a file, or you can pass the parameters like any parameter, the string parameters or integer parameters, and those parameters are passed from the command line. And while passing the parameters in a command line in a main function, like not in some normal functions or declared function, but in a main function, while passing the parameter you have to follow certain procedure, and those are like you have to define the argument counter, that is argc, that is the argument counter, how many arguments you have passed, that is like is an integer number. Whereas you also have to define the pointer to that parameters. Okay, that is argv, argument vector. So this is the way here. First is the argument counter, so like how many arguments are there, and the pointer to that arguments, to that parameters. And usually it is in this form, that is int main, int argc, character pointer to pointer of argv, or character pointer to this argv vectors or array, that means array of parameters. And now for the strings, so as you guys already know that strings are something like the array of characters that is terminated by null. And how do you perform the IO here in this string is like you just have to perform like scanf and printf, but the format is, as I have already specified, is a percentage of s. The format is s. And for initialization we have to also follow this procedure like is an array in itself, and just initialize with the following format, but it must be terminated by null here, or you can also initialize by providing double quotation mark. Okay, also you can create a pointer to that string, okay, or a empty array size, okay, with empty dimension. And similarly you can initialize in some following this format. And for manipulation there are some already provided functions in the standard library, and the library are just included by the header file, and the header file is a string, that header file. And following I have listed the following important manipulation functions for this kind of strings, and which are also provided by the string.header file, and those are sscanf. And this sscanf means string scanf. Scanf means like to scan it or read from the string. So it reads it input from the character string pointed to by the string. So this is going to just point it from the, it's just going to read it from the string itself, and it's going to read whatever values are provided in the string. Alright, so printf is like, it's going to print the formatted output to the string itself that is pointed to by the str. And whereas the str then that is going to compute the length of the string str, okay, but not including the termination or a null character. String copy is going to copy it from copy the string from the destination node to the source node. And strn copy means like CPI. This one we are going to copy the same as a string copy, that is this from destination to the source, but with the following size, that is the copy only the up to n characters. Okay, do not copy the whole item. Alright, and for string pagination, that is going to append the string from destination string to the, from source string to the destination string. It's going to append. Append means like it will add the string to the already existing string. You add another new string from source to destination. And followingly string strn cat, this is just going to append as before, but only the n characters. That means for up to n characters is going to append, not less than n or not greater than n. So it's going to append till n characters. And similarly for this function, that is string str compare, it compares the string pointed to by string 1 to the string pointed to by string 2. That means like these two strings will be compared and it's going to return a value, and if the return value is equal to 0, that means they are equal. Whereas if the return value is greater than 0, that means string 1 is greater than string 2, that means string 1 exceeds string 2. Whereas if the return value is less than 0, that means it's going to indicate that string 1 is less than string 2. And string n comparing is going to compare just n number of characters, not whole the string. So if n number of characters between these two strings are same, then it's going to return 0. That means these strings are equal. And similarly, those situation follow, those return value are returned. And lastly, the important ones are string chr, strchr. What it's going to do is it searches for the string for the first occurrence of the C, that means the occurrence of the character C, and it searches in this string that is pointed to by this string, the occurrence of this character in this string. So if the occurrence, so whenever this character occurs, it is going to return. Whereas if the character do not occur, then the null character is returned. Okay. And null pointer is returned. no matching is found. Now for str that is going to check for the occurrence of the substring, that is this string 2. This function is going to check the occurrence of string 2 in string 1. This string 2 is a substring and string 1 is a string in which this substring occurs or not. This is checked here, and so whenever the substring is, if this substring is occurred from that particular location, it is going to print out the all the string to the new line character is released. So that means it's going to return the pointer to the first occurrence in the string 1 of any occurring tag sequence of characters specified in string 2, or a null pointer if the sequence is not present in the string 1. And those were for strings. And now for the characters, there are also special header files for characters. Those are included by C-type header file, and we have like functions for to check like if the character is a digit, for like this function is digit and is lower, for to check that if the past character is in the lower case or if it is in the upper case. Then for is upper, okay, is alpha for to check if it is an alphabetic character, or is space to check whether the past character is a white space. That means white space character are some standard characters that are this space character or tab character, slash p, slash n, that means black slash n, there's a new line, black slash b, there's a vertical tab, black slash f is a feed, whereas black slash r is a carriage return type. So it checks for those kind of standard white space characters. And lastly, the upper function is going to convert from lowercase to uppercase letter, whereas from to lower is going to convert from uppercase to lowercase letter. And lastly, now for manipulation of the files. So you have to follow 5 procedures to manipulate the files of character type. Alright. So all the file of characters are manipulated by 5 phases. And these are: first you have to define the pointer to that variable, that is by doing this type of file. Just declare a file pointer, and then you open the file, that is using this function fopen. And the pointer name is assigned to fopen function, providing the first we provide the name of that particular text, and the instruction, that is like what you are going to do with this file. Either you are going to read or write. If you provide R, you are going to read it. If you provide W, then you are going to write this file. And similarly, to open the file, you can follow this procedure, or also you can define the name and then just provide the name as you define the constant name with certain value. You can use this constant here, or you can string copy the name with in another variable, and then just open with that particular name and write it, or any action that you perform. And thirdly, what you have to do is you have to check this file pointer, because you have to check whether this file pointer is null or not. If it is null, then you have to standard out, like you have to print the null pointer exception. Okay, yeah, now for the input and output operation for that file, you guys have to do the use this following while okay, you have to use the following functions. Like what I am using here is like I'm using the fscanf. What this fscanf is going to do is like you are reading from the file pointer that you have, you are opening the file, right? You use this the file pointer is assigned to the function that opens the file and reads the file, and what it does is like scans and the following string of this format %s, and what it does is like just scans and directs the value what is scans from the file to this directs to this location, that is a string, and this string is a variable that is declared, right? And it just keeps on scanning until the condition satisfies. Like while this condition satisfies, that is not equals to end of the file. If the scanning doesn't reach to the end of the file, that means if there are still more contents in the file, then this all the contents will be stored scanned, and they will pass through the they will be stored in this location, right? That is a string. And whenever, like whatever you scan here, and you perform your action here, all right? Or you have the second method for doing the input and output operation in the file, that is like you can use this function that is fgetS. That means it's going to get the string, means but you are going to get the string, but here you have to provide the length, so the maximum size of that string. You read from the file pointer, okay? You read the string of maximum length and you store it in this string, alright? Whenever this getting the string of this maximum length is not equals to null, you are going to get the string from that file. And secondly, you can perform also the whatever action you desired inside the loop, right? And ultimately we have to close the file, close this file by closing the file pointer, okay, by passing the parameter as a file pointer. So similarly you close the file and then you close the file operation here, and the manipulation of file is closed here. So lastly, okay, now let's investigate this structure. Then to investigate this structure, we have to first define what is the structure. And because as you guys know that I provide you some fundamental basic types that is provided by the C, right? Those were integer, character, float, such like that, like the long, float, int, double, something like this, as a some fundamental types of data structures, right? But what you can do is you can also construct your own or design your own type, and this design your own type is done by using the structure keyword. And we are going to design a structure that consists of collection of types. So what you do here is you just create your own type, okay? And how can you do it is like, first we have to define the type of the structure. And how do you define the type of the structure? Is like providing the structure, the name of the structure, and inside the brace that we are just list the types, whatever types you want to define. Then secondly, what we have to do is, after defining, we have to define the variable. First you define the type of that structure, then you secondly define the variable of the structure. Alright, and what can be also done is like you can define the type and variable at the same time. So here I define the type and the variable separately, right? First I define the type, then second I define the variable. And now for type and variable together, it is defined in such a form like structure, the name of the structure, and similarly provide the fields, the name of the fields here, and lastly the variable, the name of the variable is also defined and terminated by this semicolon. Or you can also just define define keyword to define that type, okay, with that synonym. So this means like this the structure will now as a whole you can define a synonym, that is a type name, and this type name is used to define the variables for this particular type, right? And now to access the fields of that structure is like you can access the field by the name, whatever variable that you define, can access the field. Means the field are the type that is inside the structure by providing just the dot operator, like the first variable name dot the field name, and similarly you can access the fields of that structure, or by the reference, that means by using the pointer you can also point to that particular field name and access the field. Okay, and by using the reference you can use two forms, like you can use the pointer name using the star symbol and the dot product, the field name, or the pointer name with the arrowhead and the field name. And you guys can also have the nested structures, not only the structure, but nested structure, that means a structure inside a structure. So how do you define this kind of nested structures? Then it's like define the structure as I have just defined before, and then inside the structure you can have also another structure, that is like you can say a structure DOB, that's the date of the birth of this teacher, will be like the day, month, year is also defined, and the particular variable of this structure is also defined here immediately, right? For the structure teacher, I define another structure, the date of birth, that consists of date, month and year included, and the variable of the date of the birth is structure is defined here, DO birth. And to access also this kind of nested numbers, you can use the dot operator, but to access the inside structure you have to use the another second dot operator, like you can check here, and when it's this teacher one variable is accessing the first structure, that is DO birth, then this first structure is going to access the inside structure field, that is a month, right? That is the way I would stand here. Alright, and for the array of structures, I have like is a array means is a type, a collection of same structure of same types. It's a collection, so it says like multiple. It's an element, collection of elements of same type, and the value is defined, like variable is defined here, like book with the arrow box with the dimension is provided here, right? The 100. And for this array of structure you can also access the field of this kind of structure, and what you have to be careful is that just provide the index, what index, like which array is trying to access among the collection of the array, which array is trying to access the field, so you have to provide it by providing the information of the index, right? And lastly, I will show you how to pass the structure to the function. And we pass the structure to a function by reference. And how it is done here is like you can see here, what I have is I have defined a structure as a card information. It's a card that has this type, that is type as the structure inside, and you guys have to pass by reference, and whenever you pass the reference, the parameter passed is the address of that variable that you have defined. So you pass the address of this variable, this card, and when you the print out the field accessed by this variable card C. When you access the field face and when you access the field number, you will have to print out this B and number, that is 5. Alright, so what happens is like it's just passing the by reference. Pass by reference is like pass the address of this card, means the address of this card, so that to this location this value will be just they will be written, so that this value will be stored in this address that is passed by the reference. So now this pointer that is pointing to this address, okay, is going to store the following values to this address. And now when you access the field, this pointer is accessing the face, it will be B, and this pointer is accessing to the number, this will be 5. And similarly this will be printed in this by this printf function. Alright, and this is one of the way to pass the structure to the function. So alright, thanks for listening guys, and this was all about the basic concept of C, and then we'll come more with the following concept and contents that I have promised to talk about, right? All these contents, one by one I will be dealing with these contents, providing you some kind of sample examples and many more. So it's like that. Okay, so thanks for listening.